Hello everyone. In this video we will do some examples for arc length of parametric equations. The first one says find arc length of one arch of cycloid defined by circle of radius a. So the parametrization of such cycloid is given by a t minus a sine t, and y is a times 1 minus cosine t, and t goes from 0 to 2 pi for one arch. Yep. So then arc length is given by integral from 0 to 2 pi of square root of derivative of x squared plus derivative of y squared, then dt. Derivative of x is a times 1 minus cosine t. And derivative of y is a times, derivative of minus cosine is just sine t. And well, this would give me, I can multiply, expand everything. So I write a squared minus 2a cosine 2a squared cosine t plus a squared cosine squared t. That's the first part expanded, plus a squared sine squared t. Here I can keep a there, but you see I can factor out a squared and it will come out as a when I take it out of the square root. Then here this will give me 1. There's a 1 there also. This will be 2 minus 2 cosine t dt. Yes, so remember that. So we have now this integral. We have to find it. Remember the half angle formula that we have, like for sine squared. This is a 1 or half of 1 minus cosine alpha over, so 2 alpha. Yes. Here now I want to go backward. I want to take 2 alpha to be t. Then 1 minus cosine of t is going to be equal to sine squared of t over 2. Okay, but that is when I have half there. Now I can multiply it by 4, so this will give me the result that I want. 4 times sine squared alpha is going to be 2 minus 2 cosine. Oh, then the alpha is not there. I just make everything t. This is t. So this is what I have now. So a integral 0 to pi integral of 4 sine squared t over 2. And well, that gives me 2 comes out, integral 0 to pi. Well, square root of sine squared, this is absolute value of t over 2, sine of t over 2. What happens here is that you notice that if you draw the sketch of sine of 2t, will go from 0 to 2 pi and then go down. So on this interval, this is sine of t over 2. This is positive, so I don't need to be worried about the absolute value, and the whole thing on that interval is just sine t over 2 itself. Integral of sine over t is 2 cosine, or negative 2 cosine of t over 2 go from 0 to 2 pi. Okay. So we have 2a, negative 2 pi, that's a cosine of 2 pi over 2 is just pi, minus negative 2 cosine of 0. Okay, so this is 2a. Cosine of pi is negative 2, so 2 there plus 2 times cosine of 0 is another 2. And then the result is 8a. And that is what we were looking. So that's the length of one arch of cycloid generated by the circle of radius a. Okay. I have also another example. This one asks for the integral. Just find the integral which computes the arc length of the spiral curve. So this spiral curve, you can try to sketch that. It will give you something like this. We will study these kind of things later, but you have to be able now to see why this is the graph of that guy up there. Okay. But we don't need to have the graph. What we need to do is just go 0 to 2 pi, square root of derivative of x. So cosine t minus t sine t plus derivative of y is sine t plus t cosine t, then square dt. We have to simplify that part. So this is cosine squared minus 2t cosine t sine t plus t squared sine squared t plus sine squared t plus 2t cosine t sine t plus t squared cosine squared t dt. One thing nice is that this cancels with that, and then if you take cosine square plus sine square, you get 1 there. So integral of 0 to 2 pi, 1 for that, plus you see there's t squared times sine squared, t squared times cosine squared. That will give me just t squared. So this is the integral which will give us the arc length of this spiral. The question is asking for integral. I suggest so you continue evaluate this integral. This is nice practice. You have to do several things to evaluate that, but I will leave it for you to find the value of that integral.